Okay. Welcome to ADoBo. This is automatic detection of borrowings. We had a shared task on detecting unassimilated lexical borrowings in the Spanish press at IberLEF. These are the organizers of the task, and for my brief presentation, I'm going to be covering two things. One, what is lexical borrowing and why it matters as an NLP task? And number two, what was ADoBo 2021 shared task and what were the results that we got? Okay. So first thing, what is lexical borrowing and why it matters? So lexical borrowing is basically incorporating words from one language into another language. So let's say that you are speaking or writing in Spanish and you use words that come from English. So here are a list of quite frequent lexical borrowings that in Spanish we use and that they come from English, words such as podcast or app or online, crowdfunding, all these are words that exist in English and that we use them in Spanish. Lexical borrowing is a type of linguistic borrowing. Borrowing is a bigger area, and lexical borrowing is only revolves around words. And because borrowing means using words from one language into another language, it means combining in a way two languages at the same time. It's related to code switching and have frequently being described as a continuum, borrowing and code switching. What is code switching? Code switching is a linguistic phenomenon where a bilingual, someone that speaks two languages, switches from one language to another. So because you have, because in borrowing, why is not the, I'm sorry, because lexical borrowing and code switching both involve dealing with two languages at the same time. They have been described or compared as being similar, but there are some differences between the two. So code switching is something that is done by bilinguals, and that means that the person that is switching from one language to another language, let's say a bilingual that is switching from Spanish into English and the other way around, has competences in both languages. So the grammar compliance of the code switches, people that only speak one language will still use words from another language. So the grammar compliance will be only in the recipient language. So if you're speaking in Spanish and you're using words from English, you're making your borrowings comply with the Spanish grammar and the Spanish system. Code switches by default, by definition, they're not integrated into the recipient language. Whereas lexical borrowing, well, they can be eventually incorporated into the recipient language. In terms of NLP approach, code switching has been approached as a sequence labeling task where each token receives a tag. So it's similar in a way to the way part of speech tagging works. Whereas in lexical borrowing, it has also been framed as a sequence labeling task, but we are interested in just extracting certain spans of interest. So in that way, it's more similar to named entity recognition than it is to part of speech tagging. More on code switching later today, because we have Constantine Lignos here, who is going to be talking specifically on code switching. So, okay, why is borrowing an interesting task for linguists? Well, borrowing is basically a manifestation of two very interesting phenomena. One, how languages change, and two, how languages interact. And these two issues are basically an area on linguistics on their own. So diachronic linguistics and contact linguistics. Second, why do we have borrowings? Well, sometimes we have a new invention, a new thing, a new reality that comes with a new word. So let's say the word software, for instance. The invention of software came and arrived into a new community or a new society with the word itself. So you have a new reality and the word, let's say that the word came with the thing. This is a source for new words and therefore is relevant for lexicography, for people that compile dictionaries. But sometimes that's not the case. Sometimes we have an old reality, something that is definitely not new, but we start using a new word to refer to that. An example of this, in the last decade or so, we have seen how what used to be color carne in Spanish is now used sometimes in fashion magazines and things like that as color nude, which is basically the same, but we now use a word that comes from another language. The same has happened with the word barato, which means low cost or cheap, but now we refer to some things as being low cost instead of saying barato. But we already had the word barato. So why are we using a new word to refer to something that already had a name? Well, sometimes it might be that the foreign word is associated with linguistic prestige. So a new word or the borrowing is perceived as more prestigious as the old word, which is interesting from a social linguistics point of view. But this is by no means new. We've seen this before. In the medieval Spanish, you had a word to refer to oil, and this was óleo, which came from Latin. But because of the contact of Spanish or medieval Spanish with Arab, we incorporated the word aceite, which was the one that came from Arab language. And that's what we actually have today. And last, having a borrowing that enters into the language, it means going through the process of linguistic adaptation. So it means making the borrowing comply with the spelling system and everything from the language that is the recipient language. So why is borrowing relevant in NLP? Well, first, borrowings are a common source of new words, which means there is a common source of out of vocabulary words. So if you have a system that was trained on some data and then you find a new word that your system has never seen before during training or anything, and it's a new word, well, there are chances that the new word will be a borrowing. And in fact, this means that automatically detecting lexical borrowings from text has proven to be useful in NLP downstream tasks. So things like parsing, text-to-speech, machine translation, these are systems that have used lexical borrowing detection. And in the last decade, there has been a growing interest in the influence of English in other languages. This has been a hot topic in linguistics, particularly revolving around English lexical borrowings. And we've seen work on automatic detection of English borrowings, which are also called anglicisms, in other European languages such as German, French, Italian, Norwegian. You have the references there. In Spanish, not that much, not that many works. There's been some exploration of the topic, but it hasn't been that explored. So that was basically the reason for having ADoBo 2021 shared task. We thought that this would be an interesting topic to perform on Spanish language. So what was the task about? The task was detecting unassimilated lexical borrowings in Spanish newswire. What does unassimilated mean? It means that we are dealing with borrowings that have not been integrated into the recipient language. So if you, like the example that we had before, football, which has already gone through spelling and orthographic adaptation, that's already assimilated. We're interested in words that have not been assimilated. Lexical borrowings, we're dealing with words. In Spanish newswire, why? Because, well, newspapers have a tendency of using borrowings. You have here a bunch of examples of what type of borrowing we're referring to. So bestseller, animal print, or patchwork, for instance. So borrowing detection might seem like a simple task, like, well, we could just use a dictionary and do dictionary lookup and deal with that. But if you think about it, it's harder than it seems, because you have prime time, which is a borrowing. But prime is written prime, which happens to be also a form of the verb primar in Spanish. And the same happens with time, with its time, and it's also a form of the verb timar in Spanish. This is probably my favorite borrowing, social media, because social is also a Spanish word, social, and media is also media, which is also a Spanish word. And you can see this too as not being borrowings at all. And actually, media social is not a borrowing, but social media it is. And not necessarily every English word that you find in the text will be a borrowing, because you have things like movie titles or song titles, such as Sgt. Pepper's Lonely Hearts Club Band or Eternal Sunshine of the Spotless Mind, which are all English words, but these are named entity. These are proper names. So these are not borrowings. And in fact, because of all this, prior work that was based on dictionary lookup produced not very good results. So what was the task about? What we did was we distributed a corpus of Spanish newspapers, and these Spanish newspapers were annotated using two labels, two tags, Eng for English borrowings and other for borrowings from other languages, not English. We use Connell format, and we use BIO encoding for the annotation. Why BIO encoding? Because borrowings can be single tokens, such as app, for instance, or multi-tokens, such as machine learning. And in machine learning, the borrowing is machine learning. Is not machine is a borrowing and learning is another borrowing, is one borrowing. This is an example of instances in the corpus. As you see, most of the words are labeled with O, so not a borrowing. But you see here, there's batch cooking, which is a multi-token borrowing, and is annotated as such. And the one on the right was probably my favorite headline on the whole data set, which was benching, estar en el banquillo de tu crush mientras otro juega de tu titular. I think this headline is fantastic. It includes 2 borrowings, metaphor. It's and if you think I'm making this up, this is the headline. This was published at El Diario on December 2020 and was part of the data set. These are the counts. We provided training set and the development set annotated. We provided participants with the training set and development set. And then they were given a test set that they had to annotate using their system. We wanted to make sure that there were as many unique borrowings as possible. Why? Because it wouldn't make sense to have, let's say, just 10 borrowings that appeared on training and on dev, and then the same 10 borrowings happening in the test set. We wanted to have as many and as diverse borrowings as possible. The evaluation was done using SeqScore, which is a Python package for evaluating sequence labeling tasks. We use F1 as the official metric. The evaluation was done exclusively at the span level. This means that we didn't give partial credit or some credit to partial matches. If you wanted to have some credit at all, then you will have to get the whole thing correct. And we also performed some additional evaluation, not for the official ranking, but things like removing orthographic cues to see how well the systems performed when there was no orthographic cues, such as what happens if we remove all the quotation marks on the test set? Will that change? Because after all, many borrowings tend to happen between quotations. So if we remove all the quotations, will the system be capable of detecting those borrowings or not? And the same with lowercase. If we transform all the test set to lowercase, will that confuse the systems or not? So we had some additional evaluations performed. But this is the final ranking that we got. We received 9 submissions from 4 different teams. The lowest F1 was around 37 and the highest was 85. So there's the range was quite big. We didn't receive papers for every system that was submitted, so we aren't sure on how of the systems were working, but we received 2 papers. One was the Bet Forever team, which they combined several CRF models. They trained them on different portions of the training data. And then they used this model to annotate a freely available open corpus in Spanish. So what they did afterwards was retrain the models with this automatically labeled data. And their F1 score that they got was 40. Yeah, 40. And we also got Versailles submission, who was Javier de la Rosa submission. He experimented with using supplementary training on intermediate level data tasks, and he also fine-tuned several multilingual language models, such as multilingual Bert and Roberta. He got a F1 score of 84, and Javier de la Rosa, who should be in the room, will be now presenting his system. And okay.
Okay, I'll go ahead and share my screen.
Yep.
If I can find it, of course. All right. Can you see the presentation? Yes, but do you also see the entire Google Docs thing, or just the presentation?
The entire Google Docs.
Oh, damn.
Yes.
Sorry for that. What about now? Be better?
Great. Perfect.
Okay. Hello, everyone. Thank you, Elena, for that great introduction to the shared task. In this presentation, I'm gonna talk about how sequential learning or supplementary learning is not really effective for the lexical borrowing of in Spanish newswire. I'm gonna give a brief background because Elena introduced to great detail all the aspects involved in lexical borrowings, but there are a few of them that are important in the approach that I took for this specific set of experiments. So speakers undergo sociopolitical and sociocultural changes, and usually that have an impact on their existing lexic repertoire of words. A common mechanism driving this kind of language on a specific word formation is usually the borrowing of words from one specific donor language to the recipient one. But usually this word must somehow feed into the morphological or phonological features that the recipient language exhibits. Before this assimilation happened, both the adapted and unadapted version of the same words might coexist. For example, we have whiskey, which is the original English orthographic version of the word whiskey, the liquor, and then we also have whiskey, which is the adapted version of the same word. And both of them can be found, both of them are actually as part of the official dictionary for Spanish by the Royal Academy. What words and how do these words enter a language allow us to gain an understanding of the development of a language, and that's when this shared task at the IberLEF 2021 comes in, because it tries to detect automatically this borrowing in annotated corpora. As Elena mentioned previously, most of the work has been focused on words of English origin, which we usually call anglicism detection, and only a couple of works have explored the topic of lexical borrowings for Spanish. In 2017, I think it was a PhD thesis, tried to build a binary classifier using just some sort of algorithm, but he highlighted problems identifying code-switching or even adapted loans. So the performance was not really great. And in 2020, coming from a master thesis, there was a big corpus of Spanish newswires in which several models were also tested for detecting borrowings of English origin and also other origin. That other is not limited in any way, so they could come from any other language that is not English. And the performance reported was great. So those are the only two options that we have for in the Spanish realm of this problem. So the hypothesis for this set of experiments that I ran was that there is a common pattern in the borrowing of words. So usually content words are much more frequently borrowed than function words. Words like nouns or verbs more commonly borrow than words like conjunctions or even prepositions. Right, that's one part of the background of the hypothesis. So also a pre-trained language model, as far as I knew, had not yet been used for this kind of automatic detection of borrowings. So the hypothesis was maybe we can use existing pre-trained language models, which are these huge artifacts that try to predict the next word given a context. Could this pre-trained language model be somehow fine-tuned on other existing tasks of morphological and syntactical nature in order to better detect borrowings? That was the hypothesis that I had. And then I have to introduce a technique which is called supplementary training. In supplementary training on intermediate label data task, which is somehow shorted as a STIL, also called sequential learning, it's a technique that is split in 3 steps. First, you have a large language model trained on a semi-supervised task, usually with the goal of MLM, which is a mask language modeling objective. That means that you give it a chunk of text, usually 512 tokens of length, and then you mask out a word from there. You mask it. So you try to train the model to predict the word that is missing based on the context. So once you have done that on a massive amount of data, like hundreds of gigabytes of text, the model is capable of predicting this word, and it has been proven that it's also possible to adjust or fine-tune this model for other tasks that are based on a supervised setting. So the idea is, okay, we have these big models that we know they work. There are also other tasks for which label data exists, for example, for name entity recognition, part of speech tagging, and tasks of syntactic and morphological nature. So maybe we can take these models, train it, or fine tune it on these other intermediate tasks, and the resulting model can be further fine tuned on the target task that we have. In this case, our target task would be the automatic detection of borrowings. This supplementary training, as defined by their authors, which is not a technique that I have invented at all, they say that the language model starts pre-training with further training on data-rich supervised tasks. That's a very short way of saying the same thing. So there are results that this technique works fine for sequences when they use natural language inference as intermediate tasks. They have reported better scores on the GLUE benchmark for BERT and also for ELMO type of language models. NLI is usually a kind of task that involve making a statement about a couple of sentences. For example, you have a sentence like I'm going to the mechanic, and another sentence that I'm sleeping all day, and then you have to say if there is entailment, contradiction, of if the two sentences are neutral. So there is evidence that training on these kinds of semantic tasks might improve a target task if you use it as an intermediate task using the STILTs. There's also some evidence, which is kind of new, is for a few months ago, that might also work for token classifications. So for example, you use a part of speech or NER or emergent entity recognition as intermediate task. And there's a huge study that tries to cross-reference how each of these tasks used as supplementary training is impacting the other tasks as used as the target final task. And they all benefit from each other. So that's what got me to the idea of actually using this technique for the automatic detection of borrowing. There is also evidence that using this technique is good when the training data that you have is not huge. So it's just in the perfect range to try these approaches. So my hypothesis was that can we use existing huge retrained language models fine tune other tasks to quality? So that basically, if a model is capable of performing for tasks like recognition, passive speech, code switching, or even language identification, those models, in theory, should also be able to perform well at detecting borrowings. So it's very much models and of model for multilingual, which is under 12 years instead of 24. There's also a technique for extracting monolingual models from multilingual models. So I use one of these extractions for Spanish. So I extracted the Spanish to also be able to test it. And I also consider the multilingual version, because usually borrowings come from different languages, and in this specific case, we have borrowing from English and other languages, right? So I extracted the 5 languages from multilingual BERT, in this case, English, French, Spanish, German, and most of the ones we take. I have my doubts about Chinese anyway. And then I also took the monolingual Spanish model pre-trained from scratch in a not so large corpus, which is called Beta. It was done like a year ago, and it already feels very old. But at the time of doing these experiments, there was no monolingual Spanish other than Beta. I also tested the multilingual Roberta, which over and over gives really, really good results, no matter what task. As intermediate tasks, because I couldn't do all possible combinations, so I just took a few of them and do the supplementary training on these different tasks, but I couldn't do all the possible combinations. So for the multilingual BERT, I used the Lince, which is a Spanish-English code switch data set that is split in 3 different data sets, one pertaining to language identification, which is of relevance for the automatic detection of borrowings, the other one using parts of speech tagging, and then another one about named entity recognition. So I further trained multilingual BERT on these 3, and then the resulting model, then I further trained on ADoBo. Also, For Beto, I used the Connell 2002 data set with NER, name entity recognition, and part of speech tags. And I further tuned Beto on the part of speech and the multilingual Roberta on the NER. The different data sets that I'm using for this further training, they contain these amounts of sentences or words and the different splits. You can see how Connell, which is almost 20 years old now, it's just 8,000 sentences, but Lindsay is almost three times that, right? So for language identification, we have 21 sentences, for NER 27, and for part of a speech more than 33,000 for training. So these somehow, because when you train further a model on these data sets, the model is somehow absorbing the information of these sets by adjusting all the weights. So the size of these sets need to be reported as well. It's not just like we are gaining performance just because of extracting ether from the air. On the other side, the ADoBo data set, the statistics that I got, which might differ from the officially reported, at the time I got that we had like 8,000 sentences for training, 2,000 for validation, and fewer than 2,000 for testing. There are way fewer tags for English annotated borrowings in the validation than the other two. In a way, that may be that may be affecting the way in which I did model selection later on in the experiments. The setup for the experiments, I use two NVIDIA GPUs with 24 gigabytes of RAM, RTX 6000. I ran a grid search for hyperparameter tuning using learning rate from 1 to 4 times 10 to the power of -5 for 3, 5, and 10 epochs, just loading the last model, not the best, but the last model. I use regular RMW optimizer, no weight decay. I warm map the training for 10% of all the steps. And I ran each of these experiments 3 times using different seeds. I'm not reporting the average, but instead the best performing model of those 3. This selection is based on the F1 microscore as reported by SecEval, because in my experiments, it was a little bit easier to integrate SecEval into the existing pipeline that I had for hyperparameter tuning than SecScore. So the results here might differ somewhat with the officially reported. This is the parallel coordinate of half of the entire set of experiments. So as you can see, I ran a ton of them, probably burn a few cloud forest. But interestingly, we can see how Eval-Micro is pretty much correlated in evaluation with testing, which is always good news, and that the more epochs, the better, and the lower the learning rate, usually the better. Although there isn't much of a difference between using 5 epochs or 10 epochs. These are the results for the validation set after training, after picking up the best models based on the F1 score and reporting for each individual label, also precision and recall. I found that the multilingual bird with 5 languages and the multilingual Roberta perform better, way better than the rest. But interestingly, the models using STILTs are very competent. They are not outperforming their counterparts. They are not outperforming multilingual bird, but they are they are giving us very good results. This is in contrast with information that you can find in the actual paper, because I made a few mistakes along the way and I have to copy the right numbers now. Now, if we see the evaluation, the results of the test set as per the validation data for model selection, we see exactly the same trend. The best model is now the multilingual Roberta, and the second best is the multilingual Verb for 5 languages. Again, the same theme for the STIL tasks. They perform really well for the English tag, for the English label, and also for the a bit worse for the other level. So in the end, the total the total score for precision recall in F1 usually are a bit lower than that. But I've kept working on these since I first started doing these experiments. A couple of very recent models were added to the pool of models to select from. So one of them is Bertin, which is trained from scratch for Spanish using Common Crawl. All the Common Crawl dams were used for pre-training these for a short number of steps. And then also Maria, which is the official Spanish language model now trained by the Barcelona Supercomputing Center. I was using the biggest model available for Maria, which is the large version with 24 layers, while Bertin only has 12, is smaller and faster to train. And I found that while Bertin is giving really good results, the STIL version of Bertin, while using name entity recognition, is slightly outperforming our best model for multilingual Roberta. So that's something interesting that we need to investigate further. So as conclusions, supplementary learning might not be as effective for token classification of borrowings as, for example, it is when using natural language understanding tasks as intermediate tasks for sequence evaluations. Supplementary task flagging all the tasks from part of a speech or name entity recognition might mean that the model has a hard time figuring out which of these ones are NER tasks that are actually also borrowings and which one are only NER tasks that are not borrowings. That's one of the conclusions that I mostly get from the study. Also, strong second best models always using STIL with fewer epochs, and that is important. STIL reach almost the same amount, the same performance as the non-STIL version of the models, but with fewer epochs. For future work, I plan to test on other intermediate tasks that might become available. For example, there is Capitel, which was a closed source data set that might be released soon. I would like to test autoregressive models like T5 or maybe GPT or even token-free models, because the main problem with this kind of models, and that's the reason why I test the multilingual models, is because they are dependent on our vocabulary. So if you get a lot of out vocabulary words, the performance of the model might decrease. So if we use token-free models in which you are working directly with the Unicode points of the characters instead of the actual words, you may gain better regularization of the model and probably get a better score at the end. It's also more robust when faced with orthotypographic errors. I also think it's a good idea to try hybrid approaches. For example, leveraging things like anagrams and add that to the vector of features that we are finally trying to train on. And over, conditional random fields have proven to be very useful when put on top of an existing classifier. So that's also an avenue for further research. The paper is available on the Zero website, also on archive, which is going to contain the most updated version of the paper, as I plan to keep working on it. All the code and release, all the code is open source, released on GitHub, and the best performing models, the weights of the best performing models are also available in Hugging Face. A few of these links might not work yet, but soon they will. And that's it. Thank you very much. Questions?
Thank you so much, Javier. That was excellent. And I'm super happy to see that you've continued working on the models and getting new results. I don't know if there are any questions. Participants can either raise their hand or unmute themselves or post them on the chat. I do have one question in the meantime. I think we have a couple of minutes. Do you have any suspicion, any theory or any idea on what's the difference between these new models, Bertin and Maria, which, by the way, excellent names, on what type of data were they trained on, or if there's any difference in the training data for those models that might give an explanation on why they're performing differently or why they could be more useful, or?
Yeah, Maria was trained with what it feels like limitless resources, right? They took the National Library of Spain entire archive.
That's the one from the.
That's Maria.
Ah, okay.
So they went to the National Library. They talked to them. The BNA agreed, and they gave them terabytes and terabytes and terabytes of data. And they cleaned it and cleaned it and cleaned it and cleaned them. And they end up with like, I think it was like 500 gigabytes of pure, clean Spanish text. So if you're working with pure, clean Spanish text, that model is going to excel. But when you do tasks that mix languages, like the one we have here, which is ADoBo, in which not a lot of the words that we're trying to detect are included in the vocabulary of the model, that model might have a hard time trying to perform well. On the other side, we have Bertin, which is trained on common crawl data. The cleaning process is not as exhaustive as it was for Maria. We basically did it in 10 hours. And it's also seeing more English. It's also seeing more French, more German, more stuff. We use a language detection tool that is not always working, right? Sometimes it fails. It detects something as Spanish that might be Italian or Portuguese, or I don't know, or maybe Catalan or things like that. But that kind of serendipity in the long term makes the model work better when you have tasks that require multiple languages. And we have seen that over and over again. For example, if you get a multilingual model and then do further training on a label monolingual huge corpus, that model might perform better in some cases than the monolingually trained model. But again, there is also a lot of aspects to take into account here, since from the implementation of the actual code, the bits and pieces of how you implemented the solution and the model, to the way in which you are doing the evaluation, right? It might be that the range in which you do the hyperparameter tuning is not the proper set of landing rates, for example, or you need to try a different regularizer or an optimizer. This feels a lot of the times like you're just giving a huge control, and you have to find and tweak all of the bits and bolts to get the best model performing. That's why it's so important to give out all the code, run experiments several times with different Cs, which affects the serial number generation of the language you have chosen for doing the training. But yeah, that's my understanding of why, in this case, Bertin is performing a bit better than Maria, which is a huge, a large model than Bertin.
Yep. Well, thank you so much, Javier. That was excellent to learn about the system and see the new numbers also. So it's now just past 45. I think we can move to the
Elena,
next
can I
session.
make a quick question?
Yeah, I'm sorry. Yeah, go ahead. Sure.
I'm very sorry if this is a silly question, because I had to oversee the other session, so maybe I missed just what I'm going to ask. But I wanted to ask Javier only about the qualitative study of the results. So the overall result is like 87 is quite a high figure for a metric, which is quite difficult, no? Because it's a strict metric. So what's left to do? Have you taken a look? It's the things that the system makes wrong. Do they share some pattern? are the difficult cases are the same across all systems, or every system makes its own mistakes?
Unfortunately, I haven't looked into that yet. I still have to look at exactly what the model are doing well and what the models are doing wrong. It would be really interesting to see things like if all the models do bad on one specific case, that's something that might be need to double check, because it might be something wrong on the actual data set. So that's also a possibility. But it might also be that it's really hard to learn. So all the models are still not doing well on that. But I haven't done a study like that yet.
Okay,
Thank
you.
Thanks.
Okay, so I think we can move to the next part of the ADoBo session, which is the invited talk by Constantine Lignos. I'm going to introduce Constantine Lignos in case you don't know him. He's a professor at computational linguistics at Brandeis University. He directs the Broadening Linguistic Technologies Lab. He did his PhD at University of Pennsylvania and has worked on BBM technologies and the University of Southern California Information Science Institute. He's interested in low resource languages and language acquisition, and also code switching, which it's the topic that he's going to cover in his talk. His talk is Modeling Code Switching, Pasado, Presente, y Futuro. So Constantine, all yours.
All right, thank you. And to start things off, my video hung for a second, so hopefully it will come back. All right. So yeah, thank you for the great introduction. This is just to talk about kind of where we are in code switching and my somewhat opinionated take on it. So it's really a talk in 3 parts, short parts, of course. One is why we should model code switching at all. Second, what is the state of the field right now? Kind of where are we? And then where I think there's room for improvement, challenges for future work. So the first question is why model code switching at all? And when I started work on code switching in 2012, this was really basically a pitch that had to be made. It's a little bit more obvious now. One part of it is that we can study code switching itself. So when we build computational models of it, we can access more data. We can find out what are the code switches that speakers actually perform and what's the computational structure of them, right? So rather than just you make it, so that's the reason to model it. Another thing that's become very popular in past and late is actually say, well, we're not really modeling code switching explicitly. Like we no longer care, for example, in some tasks about saying which languages each of these tokens come from, but rather if you have a sentence that is a mix of English and Spanish, can we just do kind of ordinary NLP on it anyway? In other words, can we just do a task, an NLP task we were going to do anyway, but make sure that it still works when there's code switching in data? So these are sort of the three major camps. So here are some actual code switches. This is Twitter data. This is part of a corpus that I'll talk about a few times in this talk that Mitch Marcus and I worked on and had annotated. So here's the first tweet. Sorry, I'm at work, babe. Trabajando like a good girl. ¿Qué haces? Estoy entusiasmada porque voy al mall con Gina. Right. So we've got this mix here. I've put colors on it for what the annotation guidelines that were used in this project might say. So here, right, we have a first sentence in English, and then the next sentence is a mix of English and Spanish. And then after that, we're sort of fully switched into Spanish. I know this is a sentence on a little bit unusual position to fish. I have a bit of situation. So, right, this is how people talk, right? This is real data. And up until this point, when other folks sort of started to work on code switching early, we didn't really have any way of dealing with this data. The only reason people kind of cared about code switching at the start was just to get it out of their data set. But if we have a system that can sort of put these colors on here, identify these spans, there's kind of a lot we can do with that. So what might the impact be of working on code switching? So one, we can start to, I think this is sort of dearest to my heart, is to chip away at the differences between the data the NLP field centers around, which is Anglocentric and focused on monolingual data, and how the world actually speaks in that, there's a lot of language diversity, most of which isn't English. And a very large proportion of the world's speakers are multilingual. People don't speak English. It's useful to have these NLP models that work in mixed language conditions, so that if you're speaking Hindi English or Spanish and English together, that still there's some kind of model that's going to function for you, if that's the way you operate. And finally, I think by doing this work, we can improve our understanding of what's actually going on in our heads when we code switch, and what are the real rules, and how can we test those at scale beyond these sort of more armchair linguistics approach, where we might come up with the rules but not be able to validate them on millions of data points. So this next part, my goal is to really kind of explain kind of how we got to where we are in code switching, and what the field has accomplished overall. And I've played a very small role in this, which I'll touch on. But early work in this area, I just want to highlight, I think this is the first modeling code switching when there is a code switch, actually a binary classification problem. So in other words, basically say, hey, a code switch is about to happen. And I say the training labels are noisy because what it is the transcript of what actually happened, right? There are many, many points where a speaker could code switch, and so the transcripts you get are just what actually happened once. So it's an extremely difficult task. And one of the challenges is sparsity. So they had relatively small amount of data to begin with, only. But unless you can force context, often code switches are rare. So they only had 239 switches in there. And their best results came from a naive Bayes classifier. I won't really jump into those features other than to say these were sort of the standard features you would have in 2008, except they did actually mark the language of each token. So it's kind of interesting, but basically you could only, you only had the left context. So basically it's, hey, looking at the previous set of words, is a switch about to happen, but you get to know what the language of the previous set of words were. And the scores were, let's say, very modest, right? An F1 of 28 points. So a very challenging task. In 2013, Mitch Marcus and I sort of put out sort of this first attempt at doing what would later become sort of really standardized by others. Of, hey, why don't we take a bunch of tweets and try to do per token language identification on them. So for example, we took about 7,000 tweets. We found about, after annotation, about 3,700 of them, just a little over half were annotated as code switching. And this highlights one of the big problems. So we actually managed, our goal was to get a target data set of about 50-50 code switching and not. And we did get there, but if you look at the true data set we were sampling from, about 7% of that data had code switching. So if you want to build a data set for code switching, or as was done here, you need to build a data set for borrowing, you often have to rely on some heuristics to really help you identify the right data. Because if you just try to annotate all the data, in this case, almost all of the annotation time into annotation and borrowings. I won't really say much about borrowings because we're all here because we care about that. Around entities, we did something very, very simple. Just have an entity tag, type tag, and say we're just not even going to evaluate these tokens. And that was done again in a much more refined fashion later. And for borrowings, like mall in the example I gave you, we came up with a rule we call the monolingual grandmother rule, which is that if you let's say you're bilingual, but you have your monolingual grandmother, and if they would recognize that word as part of say Spanish, it doesn't count as a code switch. That's just something that's borrowed or unassimilated, assimilated or unassimilated. So after this point, there's really been a tremendous amount of work in NLP, and I can't really even list it all here. But the biggest sort of impact was the introduction of calcs, the regular sort of every year or every other year workshop on linguistic code switching. And this is how the field really took off. And it started with shared tasks in language identification, token by token, kind of the same way that Mitch Marcus and I had done. But then, people really took it to new levels of formalizing the entity part of it. So language identification and NAR, then doing part of speech tagging in mixed language contexts. In 2020, we saw the Sentimix task join Semival, which was sentiment analysis on code mix situation, but also identification portion of that. And just want to highlight the richness of what's out there. So if there are a number of language pairs, there's certainly room to build out a lot of different kinds of languages, but it's more than just one language family or something like that, and it's more than one task. So I just wanted to wrap up with kind of what I see the challenges are for code switching research. And the first is, most relevant to this session, the interaction between borrowing and code switching. So can models correctly identify the differences between borrowing and code switching? And unfortunately, before and thank you for what. And so there's a very legitimate question to raise. This is on Twitter. Is this just internet speak? And I think probably the only non-standard speaker in this room, probably the least well-equipped to answer directly. But I know the native informants, I would say. So basically, there's a real challenge here. I think it would be super interesting to have a task where borrowing and code switching are both annotated, and models need to decide what's going on there. But first, we have to figure out what we want to do with it. Working with less data. So one of the things last year has been multilingual large language models, and so you can bring up in an hour with so I think the question is, what size data do you need to get code switching done, and what specifically are these models learning? So I'll just point to a little bit of an old-fashioned study that again is from my own work here. But if we're looking at sort of the blue-green line here and the kind of orange-red line here, we're looking at basically given a certain amount of training data that's increasing in a data relation study, kind of how well these models learn. And so basically, this is training two things: one, an HMM where you can set probabilities on huge amounts of model data, and then you just do kind of a little bit of fine-tuning on the training tweets. That's why the flat. And then two here is it's a structured perception. Think of it as CRF. It's basically training on thousands of tweets. And so we're getting to the point where basically at about 1,750 tweets, the two models are matching. So with subword information and things like that, it's able to pick up on patterns here in Spanish English switching. And so also this helps much about switching in mind. But we can at least look at their output on data and see what that says using this quiz analysis. So for again, some simpler models, one of the things that I've looked at is evidence for and against the functional head constraint, which basically says between a functional head like a determiner or a complementizer or preposition, or a complement, that you can't code switch there. And basically, we found is that this is true for some functional heads and not others. So like complementizers, like que in Spanish, are basically, we found no violations of this. The only time it looks like you have a violation is when your model might get a little bit confused here, right? So here in this tweet, right, they have que and apple, and a bad code switching model might consider apple a code switch, but there's not really a code switch there at all. But despite the fact that sort of linguists have argued that you can't have code switches between determiners and their nouns, there are many, many examples of them. So here we have la memory stick, la big sister, things like that. And those we could argue maybe they're idioms or lexical gaps, but there are other cases where speakers are doing it more out of creativity. So here, mi wife, obviously there's no lexical gap for wife in Spanish. Baby shower, maybe that one's a little less clear. So anyway, we can really learn about what kind of linguistic structures are involved in code switching by working on these models. So to wrap up, the last 13 years, we've really seen tremendous progress in the modeling of code switching, the evolution of so many new tasks, and that's really exciting. But even for these simple subtasks like language identification, right, the shared tasks have sort of abandoned token language identification as too simplistic, right? But there's really a lot left to be done there because, for example, their language identification is often done without comprehensive annotation guidelines. It's done without accounting for borrowing at all, things like that. And so, I think the main frontiers, understanding the borrowing code switching distinction, working with less data, and then seeing what these models can tell us about code switching itself. So thank you very much.
Thank you so much, Constantine. That was great. We have time for questions if participants want to post or unmute themselves and ask any questions. I do have questions.
Yeah, go ahead.
One thing, this might be just that I'm very ignorant, but as someone that has gone through the process of annotating borrowings and trying to tell the difference between what assimilated and unassimilated is, seemed pretty clear in the linguistics literature. But when you actually have to deal with it, then it's definitely not so obvious and it's not so clear. So I was thinking, whether the situation on telling the difference between borrowing and code switching is better defined, not for NLP or in code switching modeling, but in like the linguistics literature, how well or how can we tell the difference between this is code switching and this is borrowing? Is there a clear cut between the two, or as always, it's not? Or
no, I mean, exactly as you said, it is definitely a continuum. I think, yeah, I think there may be some, diagnostics like you might do for syntactic annotation that will help with sort of specific cases. But I think it's going to be very, very difficult. And I think what works in one language may be challenging to transfer to other languages. So I think it will be, kind of a while before we could get a really solid set of guidelines that are going to, be robust. But I think it's worth the challenge. And another big issue, I think, is doing this in text. So when you do it in audio, you do have some sets of cues about pronunciation and things like that. In text, you get, spelling cues instead, but it's probably less meaningful.
And also on the same, on a different topic, but I think that everything related to code switching that I've seen, like in Carl's workshop and things like that, are around Twitter data. So it's always social media, because being code switching something that happens in speaking, then you're likely to go like the closest information on text that you could have is a Twitter conversation or something like that. So I was curious, like, is code switching modeling possible, or has it been done on things that are not? Are you bound to dealing with Twitter dialect and internet language, or is there any other code switching approach or data?
Yeah, that's interesting. Yeah, one of the challenge, I had a fourth challenge, but I kind of cut it for time, and the other was sort of more diversity in the domains of the data. There is non-Twitter data. It's very limited. So there is one of the big Turkish Dutch code switching data sets, which is a very unusual pair of languages for code switching, was done, I think, from knitting forums. But it was a very interesting set of forum data. But there's not a lot that isn't Twitter, and I mean, I also want to raise that I'm not confident that all of the Twitter data is ethically sourced, in terms of following terms of use and all that. So it's very tricky. I tried at some point to assemble blogs that showed English-Spanish code switching. Unfortunately, it was also like when blogs were kind of dying off. So I suspect there may be some other short media out there that isn't Twitter that may suffer less from internet speak, but I'm not sure. I mean, it may be Instagram comments or something like that. But it's for good reason, it is becoming more and more challenging to sort of get data from social media. So it's tricky, and this is a little bit of sort of a needle in a haystack problem. Yeah.
So any other questions?
Yeah, but I have a couple of questions.
Yeah, go ahead.
So there are some evidence that when you train multilingual, these huge monsters that are multilingual large models, when you use them in the right way by providing the correct prompts and everything, since they are multilingual, there are studies that try to tell us that internally the representation space is somehow related to the language hierarchy that linguists build. That in a way will conform an interlingual sort of thing. So would that have a revelation like that have any impact on how you treat code switching exclusively from textual data? Could adding a speech to that equation provide anything meaningful?
Yeah, that's really interesting. Let's see. Let me start with the speech one, which is a bit more challenging. I mean, I think I think with language relatedness, there's a whole let's say a whole web of things that get conflated. So one angle I approach this from is my experience working on related languages for low resource language processing. And one of my favorite examples here is people talk about, oh, maybe you can use a neighboring language or something like that. And so I spent some time working on Uyghur, which is basically more or less closely related to Uzbek, but written in Arabic script and with heavy influence from Mandarin Chinese. So the question is, what related language is most relevant there, right? And will all of those help equally? And so it's very tricky to disentangle some things that are accidental, or let's say the effects of colonialism and these kind of things, like which writing system is used for a language, which may be determined just by who invaded it and not linguistic sort of phylogenetics. So yeah, I do think there may be some way to leverage these kinds of things in code switching. I think in reality, there are some sort of more surfacey things that tend to overwhelm. So I think for all language mixing, or including, the ADoBo task here, right? The fact that English is a lingua franca of sorts nowadays tends to overwhelm kind of other meaningful connections. So I definitely need to catch up on what the latest thoughts are on the big multilingual language models before, XLMR and, MBERT and all of that. For pretty much all of these sort of multilingual transfer learning tasks, many of the results ended up being, it's always English that's doing the work when you add in data, just because there's more data in English and there's more high quality data in English. Now that was years ago. I know things have gotten somewhat better since that point, but I'm always skeptical about this sort of claims that the true phylogenetics and historical connections between linguists, how linguists show think of language, are really showing up in these neural models that are not seeing history, but they're seeing the current reality of those languages, which are shaped by so many factors beyond language families and classifications and things like that. And I suspect, kind of to your point about text versus speech, I do think, yeah, the speech probably brings you closer to kind of the real relationships between languages, where text shows a little bit more of the kind of accidental and kind of orthographic conventions that are often affected by sort of political things and that kind of thing.
Thank you.
Okay, if there are any more questions, I think we can move on. Thank you so much, Constantine, for the talk. It was super interesting. And also, I wanted to point out that for Constantine is now 6 in the morning. Is that right?
Yeah.
So
it's 6:15 now.
So yes, thank you so much for joining and waking up extremely early and talking about code switching at 5 a.m. for you, which is, I think, impressive. Okay, so we have a few minutes left. The plan is I'm going to very briefly wrap up with some of the insights of ADoBo as a shared task. That this was the first time we organized it, so we can have some discussion if you want on this. I will give you some numbers, but this is basically just sharing some thoughts on the future of ADoBo if we want to see new additions. So let me share again my screen. Okay, can you see my screen? I'm going to assume that's a yes because I can't see anyone, but that's okay. Okay. Okay, so very quickly, some final thoughts on ADoBo shared task. So as I mentioned, this was the first edition of ADoBo, and actually, as far as we know, I think this is the first edition whatsoever on a shared task devoted exclusively to borrowing detection in many languages. So at least as far as we know. If by any chance you've heard of, oh yes, there was this other task, this other competition, please let us know, because that would be awesome to know that there are all the people there. 50 registered participants. We got nine submissions coming from 4 different teams and 2 paper submissions. One of the things that we asked after the task was done was we shared a survey among participants, among registered participants, to learn more about what their interest is, if they want to see new editions of ADoBo, and what topics they would be interested in. And here are some of the topics that they suggested. So lexical borrowing detection in all the languages, because for ADoBo we only had like borrowings basically from English, some others, but basically English in Spanish text. Semantic borrowing detection, which could be super interesting as well as tricky. So having something that, I don't know, let's say the verb aplicar in Spanish, aplicar exists in Spanish, but lately has acquired a new meaning, which is equivalent to the English apply, which would be like, I don't know, presentar una solicitud or something like that. Diachronic assimilation of borrowings, which would be the process of an assimilated lexical borrowing, a new lexical borrowing, going through the process of being incorporated into the language and going through all this morphological, spelling, orthographically process of getting assimilated. And code switching, which it was also something that came up in the survey as a topic that people would like to see more. So I don't know if you have any of the participants here, or if you have any ideas on what would be interesting to see in future editions of ADoBo, or what would be good not to see in future editions of ADoBo. But this would be some of the topics that we could consider for if we had any future editions coming up. So if you have any, this is like possibility of an open discussion, meaning if you have any suggestions, ideas, or things or thoughts you'd like to share, this could be a good opportunity for sharing. Or
so I did have a related question, which is I actually haven't seen the results of the post-competition questionnaire. So what else did people say, or were there any things about the task that they wanted to see different or something like that? I wasn't sure exactly what questions were asked.
One of the things that it was definitely something that Jordi and I discussed after the competition and the survey itself was that the test set was not that big, but the test set was like inside this background set, which was actually huge, and it was definitely too big. At the time we thought, yeah, okay, we'll make it huge. And I think that was something that prevented some people that intended to send a submission didn't end up submitting, because it was bigger than they thought and it took longer to run than they had anticipated. So let's make that concept was this valuation. I should also mention that rules are on paper and show results on the presentation of having the same test set but in different versions. So the version with no quotation marks, the version with no with everything turned lowercase, which I think it's an interesting thing to have. Like, what happens if all the test set was in lowercase? Does this break the system? Will this make the system confused about what the person was borrowing, like a person for a name, for instance? But yeah, the background set was definitely an issue. The size of the background set.
I agree.
Oh, yeah, I'm sorry. Yeah, I'm sorry on behalf of ADoBo.
It took forever to do prediction on that.
Yeah, it makes no sense that the difficult is going through an enormous background set that, and much of it.
A good video. I think, obviously not easy necessarily. Next step might be to get different sets of languages, and then basically the things are one kind of thing, and then do borrowing in those and make that somehow fast or something like that. Somehow be open to this kind of task, hopefully. If there's more language diversity, to be sort of more keen on it.
Oh, I'd love to see that happening. The thing that I'm always concerned about is that, of course, whenever you move to a different pair of languages, You're going to need people working on that language, and you're going to need annotators that are capable, like that are available for annotating this. I'd love to see Greek as one language there.
Yes, I wish I could trust myself to do the annotation, but yes.
I was surprised. Something happens around the here being the border between Spain. Or I've seen it's a language that's speech, so it's Spanish from the south of Spain combined with extremely rich English. And it's incredible. Yes, and I think there's even papers and TV shows where they speak Gaelic. So there's several code switching gaps like in this country or in Catalonia where you're going to have bilingual communities. And it would be very obvious to have code switching within the Iberian Peninsula, I think. But
I think it's an extension of what happened this year, and certainly I can confirm it has never been here, or even in the previous IberLEF like exercises like IBAD and others. So it would be interesting. To me also, so combining both sources probably would be challenging and also fascinating between what's just user borrowing and what people use in social media. Also, it could become harder to distinguish from codeswitching, which in principle you don't have a lot of that in news. So it could be closer to that, and maybe it could be interesting. Maybe starting first borrowings in news can give you good information to do the task better when you also it's mixed with code switching in tweets or other social media. So I think that's also like a natural step to make things more challenging and more informative.
And one thing that for me, it was very obvious that it was a huge limitation of ADoBo, but at the same time, I don't think it's easy to overcome, is the fact that all the data for all the borrowing thing that I've been doing, including ADoBo, is on Spanish newswire, meaning Spanish from Spain. So this doesn't involve in any way any of the lots of variety of Spanish dialects that exist worldwide. The thing being, it's difficult enough already to have a clear distinction of what unassimilated means for a given society or a given dialect. And if you're using like a dictionary, of an official dictionary, that's going to be extremely Spain-centric. So I'd love to see something concerning borrowings for Argentinian dialect, but would the annotation guidelines work straight from Spain to Argentinian? Because the word Brazil is extremely Spain-centric. So that's like, I don't know, that's not saying anything, but the Spaniards here don't know. That's an issue that we need to tackle eventually.
That's all right. Obviously, different variants is different versions, different dialects, different annotations, of course. It would be great to have that, and also the IberLEF community is a good starting point because you have people doing NLP in countries with different dialects, so it's a good starting point to recruit interested parties.
I'd love to see also something with Basque. Like Basque and Greek would be my favorite languages to see borrowing. And it's extremely different languages, like, okay, particularly Basque, but also Greek having a different alphabet and everything. I think that would be quite a challenge. It would be interesting to see.
Yeah, I do think doing, let's say, cross-script borrowing would be pretty interesting. I mean, it certainly, there are probably languages of India where it would be very interesting in, but I think it's also just complicated because the English proficiency level is just so high in India that so many people are trilingual, in their mother language Hindi and then English that it's very complicated to really sort out what's going on. But yeah, I think Cyrillic borrowings into languages written in Cyrillic would also be very interesting.
Okay, so I think we need to wrap up because there is another session in this room now.
Okay, so thank you so much, everyone and all participants for joining, and thank you our speakers, Javier de la Rosa and Constantine Lignos. We'll keep you posted on any future ADoBo sessions or ADoBo task that we have. And I guess I'll see you at different sessions at the IberLEF.
Thank you
so much. Bye-bye.
Thank you.
Goodbye.
Bye.